So it's our pleasure to listen to your talk, Aerospace and Engineering, the World's Future. You know?
Yeah.
So please try to do it in 20 minutes.
Yeah, well,
Yeah.
I can do it in 20 minutes.
Okay, thank you. Thank you very much.
Okay. Morning, everyone. I'm sure you can hear me, right? Everything's cool? Because I noticed everyone's been talking back here, and the microphone's right here. So, Jessica, everything's clear? Okay, cool. Well, guys, I'm going to talk to you for only 20 minutes because the workshop, I'll go into more explicit details about this. And where's your clicker? Okay, so move along. Anyway, so let's talk about some things I've been on recently. I was just on the Boeing's Space Launch System, and got them to a PDR, CDR level. So so things are going good, except the welding of that huge tank that they're doing. They paid $400 million for a tool to weld this monstrous tank. Friction welding, of course, which is not the easiest thing in the world. And lining up, you could do 2.5 inches thick of aluminum in friction welding very well. So on the SLS, what happened this year is, for some reason, that $400 million tool had a misalignment of over an inch. So they had to redo and reset the entire tool. So that sets the program back just a little bit. But once the bugs are out, it's going to be a phenomenal spaceship because this, let me go. Can I go back? There, okay. This spaceship right now, this SLS is going to be carrying 70,000 tons, or 70,000 pounds to begin with. And then it's going to do things and actually put people up to the space station and so on. But it's actually going to go to Mars by 2020. It's going to go there, and later on in 2024, we're going to start bringing stuff back, go to Mars and bring back stuff, and we'll also have different inhabited stuff. Now, the space station falls out of the sky in 2024. Well, it's uninhabitable. By 2028, it starts falling and tearing apart and such. So, this SLS program, as it evolves, when it goes and upgrades right here around 2024, it's going to be able to carry 130,000 pounds, which is much larger than our Apollo or Saturn had ever done. Not too much more, but it is more. And it's almost 10 times what the space shuttle could ever do. And it also can run on full throttle for 9.5 days. Okay? So when you're out of the atmosphere and into space, there is no limit to the speed except for things that you run into. So if you really wanted to run it for a day or so, you're going at speeds, you can get 1,000,000 miles an hour. It's stopping it that's the hardest part. So when you're going to Mars, this is planned, it's actually funded out to 2050. Okay? So this is our future. We are doing it. America is still in the horse race of doing space, okay? So this rocket has a lot of potential and a lot of other missions that aren't shown up here. Besides Mars, it's also going to go to the moons of Jupiter. So, a lot of money in here. This program's going to be around for a while. So, this is what it looks like. So you can see the first, it's really not going to be fired up and launching. It has to launch before the end of 2018. That's congressionally contractual. So they always put their target date to be a year ahead because they know they're going to fall back. So that's the schedule you see here. So anyway, now I'm going to talk about the cool thing of engineering, exactly what we're here for. Now, how cool or how fun is a job? You would actually base it on how happy is it? What is the happiest job? Probably besides the stress of being an entertainer like an Elvis or something, or Oprah. The happiest out of Forbes, and I think they looked at over 1,000 jobs, the happiest job in America is a quality assurance and a software engineer. Okay, that's the #1 happiest job. And tied for 9th, 3 of them, is we have, let's see, we have systems engineering. That's tied for ninth. Process engineering, and project management and construction engineering. So those jobs are your 4 top happiest jobs out of the top 10 of Forbes, okay, or with 1,000 jobs looked at. So you picked a field that isn't too high stress. The process and manufacturing one, I've seen those guys stress out on the line before, so it depends where you're at, you know. So just to give you some facts and figures, once you're graduated, your BS, okay, and then before you get your PhD and so on, your starting figure is typically $70,000. On average in California, it's about $90,000, and you can easily grow up to $120K, okay? So that's your average salaries. If you want much more than that, you got to get to director level and so on, and be shareholders. So that's the fun thing of engineering, just in case. I don't think they show you that at a lot of conferences. I speak to try people go on to different career tracks, and so I talk that way, because hopefully someday somebody will come up to me and say, you know, I seen you speak this one place, and I chose that path. You know, wouldn't that be cool, right? So that's what it's all about, sharing. So anyway, for our industry, aerospace and we are, except for oil and energy, we are the #1 exportable technology in the whole world. $5 trillion, Boeing alone is a $5 trillion in 20-year activity for building airplanes, okay, and exporting them. So that's a darn good deal. Space, I might have that over here, no, I have another one. Space, for instance, was $317 billion. Now it's up to $560 billion in a year. So space is beating the commercial airplane market right now. And that's basically because we're going to a Gen 3 type of GPS system and a communication system. So that's why, launch vehicles. So. Oh, one other thing. Like I did say, except for energy, energy is $17.2 trillion a year. That's bigger than America. That's bigger than almost any country in the world, period. So, go on. This is references of old concepts. We're going to get, so this has to be an evolutionary thing of going after space and energy and so on. And it doesn't have to start in space. We're going to actually start on land. So, let's go on from here. Okay. So, now, back in 1960s, in the late 60s, a gentleman by the name of Paul, and I forget his last name, but I know people here do remember him, started the space-based solar power thing. Said, hey, we already put things up there with solar panels. We could just beam it down to Earth and do it, okay? So I was exposed to it in the late 80s, being at McDonnell Douglas as a project manager, and so I kept up with it, and I know we even proposed it during the Star Wars time when Reagan was in office, and we proposed it for a lot of other reasons, not just energy, okay? So since the late 80s, I've been familiar with this, and then John Mankins has been doing it since like 2005. So anyway, so here, let's give you the vision of what the real future is going to be, and this is how space will be, because our space station falls out of the sky, 2024, it's history, you know. But what do you need to do future space? You need to have a space station, a replacement, and then if you did space power, then you need things that you need to actually maintain and repair, so you need some tow vehicles, okay, and some maintenance vehicles. So you'd have to have some outer orbital vehicles, not a space shuttle, but similar to, doesn't have to have the wing formation, but a tow vehicle and another vehicle that could actually do the work up there. You'd want to capture it. Now, we found out that large bodies attract smaller bodies and so on and so forth. That's the nature of gravity in outer space. When they put sugar and salt together, we discovered that just not less than a decade ago. So we know that we could do that, put it in a net, so maybe electromagnetic net or something like that, and just do that and start grabbing it. And then whatever could be dangerous and anything else that's in the path, like little nuts and bolts and washers or so on, vaporize them. okay, with microwave. But you really want to capture and use it, because it took a lot of money and a lot of time and effort to design, and a lot of high-tech material and science to make that stuff go way up there. You know, back then, it was over $100,000 a pound. I think right now we're down to $10,000 a pound, and we're trying to get below that. So DARPA's working on something with new technologies, with nitrous oxide and so on, that can do it at about $3,000 a pound or below. So anyway, so you want to do that, and then you want to have orbital factories that take this junk, grind it up, separate it, contain it in canisters or whatever, and use it. You can. Our evolution on 3D printing has sintering ever since Pratt Whitney and GE has been sintering turbine blades, and we've been doing rocket nozzles. The technology has become a lot more affordable and a lot better. So 3D printing is here to stay, and it's only grown on leaps and bounds. Almost everything on the F-35 is 3D printable. Okay, so you put that in space and start repairing stuff, evolving stuff. Heck, if we had enough time, we could have taken that space station and towed that baby back into a higher orbit and kept using it. If it's designed capable, you'd have to do a trade study to verify that things are still usable on it. So, anyway, let's go on. Oh, and control centers. Control centers like Houston, we got a problem. Did you ever see how old stuff looks? Even at the White House when they have the briefing room and the war rooms, it's ancient computer stuff on the wall. You've seen it. The actual Air Force One, if you look at the computer monitors, they're like entire walls, and they're shaped exactly to the airplane. They're perfect. You could touch them too. So anyway, it has to start doing it. And if you ever seen something like Science on a Sphere, right, projected onto it, everything has to be that way, and then you have to have ways to do it holographically around it. So we have to evolve that way on our control systems, so you can zoom up on it just like you would in Minority Report with Tom Cruise. So I know I'm talking out there, and so is James Woodward, but these are stuff we know are going to happen, and we can do it because we see them on TV and movies now. So we know we can do it. Hey, if it's in a movie, it has to be real. So anyway, so where do you start? Okay. Anyway, we're going to have fun with this. An engineering one's full of equations. I did enough time on equations. This is the stuff of the future, so we can get into that stuff later. Those are reports later. If you all have my business card, Deb, not this presentation, but the other one is on my back of my business card, and I'll have this one loaded up on my sites later, so you can always catch up on stuff. And then there's papers, technicals that go into all this. So anyway, to do this is, when I did the first publish on it, I actually got 13 different huge investors. Actually, most of UAE had contacted me right away to invest. Over $200 billion has been offered. So I went to the ISDC conference, okay, the NSS ISDC, International Space Development Conference. And I talked to the old Space Command General in charge of NASA, and he was there, a retired guy. He was in charge of Aerospace Corp too after he retired from Air Force Space Command. And I asked him about this because the Minister of Defense from Iran contacted me to fund me on this stuff too, okay? And and he said, yeah, go for it, because then they wouldn't have a reason to do nuclear, because we'd be doing space energy. We could beam it down. So the problem with it is this could be turned weaponized immediately and very easily. So that's the thing that we have to stay away from. So anyway, investors, it's available. I've been trying to push it as the only way to back the Federal Reserve dollar, because the way these Democrats spend money, I don't see an end in sight, okay? We're over our GDP. Over. So in World War II at the end, I hate to get on this side of politics, but because America had the bomb and we could have taken over the whole world and planted our flag on the whole world, we actually said, nah, you keep your sovereignty. All we ask is one thing, that only one monetary dollar is, the U.S. dollar is the only monetary fund that's internationally traded and accepted everywhere. And that was something everyone agreed to. So, did you guys know the law on that one? Well, look it up. It's the truth. I know you'll check me out. Anyway, so first of all, we got to do all the studies. We started already doing studies. I've had the White House involved on this stuff for about 4 years now. So you'll see that they're doing weather measurement and other things going on for a while. Oh, by the way, in case I never told you, I've been a California State Advisor to the White House, Senate, and Congress since 1995. So I've talked to 3 presidents, and there are 4 wise men, because they always have 4 advisors, and the Congress, and always the office, the U.S. President has an Office of Science and Technology. So those are the people I usually do questionnaires and talk to. So anyway, it's not in there, but that's what I also do, and that's why you'll see things that are in here that you're going to see in the future because it's already been told to them. So let's go on. So grow the teams, public business, design and simulate everything. I don't believe there's one catch-all. John Mankin's Alpha isn't the best way because it's got to evolve, and it's a great way. Highlands, Power Star, there's no one catch-all. You have to do whatever's best and wherever it's going to be used and how it's going to be used and so on. So we got to evolve the universities to learn this stuff. And then make this a world incentivized project, which means you get paid actually by what you produce and contribute value added to the program, not by the hours or how many people you had at that one company in that state by that senator. It's world incentivized based on target and task, which is very defined. We've been defining it for the last year and a half. It's going to be more defined as we go into the future. These are basic things to do an entire system. I'll go into more detail about that later. There's John Mankin's Alpha system. He did that book, The Case for Space Solar Power. And my Congress, Dana Rohrabacher, gave him the $25 million to do this study. I was just at his birthday party with Buzz Aldrin. And that's a great study. It's very detailed and to the point. It's over 400 pages and a lot of hard technical data in it. Did a great job. And then he got that ego about, well, it's my way or the highway. So he's really on his Alpha system. He wants to evolve it because they're really cool. I'll have to talk that at my afternoon talk. I'll talk details in that. This Power Star is cool too. But an entire system has to have solar energy, beam transmission, ground collectors, data, of course, evolving your data systems, standard stuff. Turnkey system. Now here's the cool stuff. When you look at a full turnkey system, you always look at adaptations and what you're going to do in the future. Working on the future combat systems, we were looking at, it wasn't even going to be put on this planet until after 2016, and we looked at out to 2035 to 2050. So you always look at the adaptation of how you're going to use this stuff later. So I don't know what happened. Weather control is another way. Huh. Oh, they're advertising for us. I seen you had the advertisement for some kind of software blocker or antivirus or something come up on you. Yeah. Anyway, so eventually do a weather taming system, and I'll educate you on that later on today. Tracking beam. You could use tracking beams to carry, after you get out of our orbit and you want to push people to Mars, you use a tracker beam to push their butt to it. It's not hard to push the energy to them, okay? And you'll see how we can do that later. I've already did a white paper and proposal, a ROM proposal, BP or something to NASA on that stuff for the Mars mission. And the other cool thing is it's been looked at by other people, other universities, is desalination with this energy. How do you fund it? This is just funding profiles. These are the right agencies to get involved. Also, foreign agencies have to be involved, like ESA and so on. If we just did Federal Reserve, these would be the guys, okay, that we'd have to fund. But if we go international, which it should be, as long as politics don't get in the way, which they will, you know, those are groups we need to use. Now, I don't know why that happened. Sorry, guys. I'm my own biggest technical difficulty today. Go to the next one. There we go. Okay, develop the best one and the best bang for the buck, right? And really, if you had all the energy you needed at any time, anywhere, do you really need to fight over oil? Really? So that really helps. And if you can desalinate water, would you be fighting over water? And if you did those batteries that make water and it's abundant, would you fight over it? So anyway, building the right teams. I've been building the right team for over a year now. I still need to build a bigger one. I'm hoping that you'll all keep in touch with me because I have the funding, and not until next year will I start up the company to do that. So the beginning of next year, it's funded and started. So I've held the investors off for a year. So anyway, and then doing it the right way, where you actually do full simulation of the whole system, okay, and each little aspect of where it's falling weak, okay. You have to look at it and do real hyperlinked logical trade studies. And the guy from Boeing knows exactly the details it takes to make the evolution design studies to make a spaceship or an aircraft or anything really awesome. So, everyone knows there used to be a video from NOAA that showed in 100 years the ice caps melting. Did you know, let's see, it's not in this one, let's go to the next one. Did you know that we were supposed to be going back into an ice age? Within the next 15 years, or 15,000 years, we were supposed to be covered in ice again. Did you guys know that? Did nobody tell you? After our planetary came to that planar with the entire universe, okay, at the December 21st, 2012, from that day over, TIPS goes back into an ice age. That's a fact. Now, don't take my word for it. There's a video link right there. It's a documentary called Water in the Future. And, the Future of Water, that's what it is. There's a hyperlink to it. And if you watch, there's a 4-part series about water. And the Middle East has a huge thing to play with it. Did you know that there's this part in Tibet that, and it's a river now, but there's over 2.5 miles of water and rivers of what has never seen the sun in the day for over 1 million years. And now they have water running there. And then, and that feeds everything downstream. So capturing Tibet was the biggest important part for China because they need that water. So when you watch that, you'll learn why. Of course, we all know tornadoes and hurricanes are only going to get worse. And what follows is after everything's blown up like that, then blah, blah, blah. So I'm going to stop. I'll go one more. Let's see. Energy. We use 132 terawatts a year. Per year for the whole world. And so that really is about 11 terawatts a month, okay? The system I've conceived originally, what it has to be, like around 400 of these little balloons up there, which is from a NASA concept in 1960, would take about 400, okay, which would have done 50 terawatts. So we're going to break that in half. So anyway, so we can easily do this, and the demand for this is dramatically higher. And that's all I have time for right at this moment. Oh, this is a good one. I just love these people. We're on the verge of a global transformation. All we need is a right crisis, like Jimmy Carter had, or global warming, which actually, from satellites, we've proven it's true. But anyway, new world order. Yeah, without the dependency. That's our goal. Okay. So, and this is the safest way to do it. And that's what the effects on Earth, and there's energy and how the system works and the studies that has to go on and so on, and then that's falling out of the sky, and then here's how we develop it and evolve it, and then here's an actual method of doing it with detailed systems. And this is Mankind's very evolved schedule, which works very well and very smart. Just like their USB. That went from 16 megabytes to 128 in how many years? So, I'm done. We'll have to talk
Thank
later
you.
this afternoon.
Thank you very much for your presentation.